Hello there, I am Michael Larson. I am with Excelon Development, and along with Matt Heuser, who is also part of Excelon Development, we wrote this book, Software Testing Strategies. So far, between Matt and myself, you've had a chance to look at a number of chapters. We have discussed them at fairly decent length, and now we're shifting into a different part of the book. The first part of the book was all about testing skills. Second part of the book was actually taking those skills and putting them into practice. And now part 3 has a lot more to do with the politics of software testing. And I think in a sense, that's one of the things that makes our book a little bit different than many other software testing books out there, in the sense that we really went there. We decided that we wanted to talk about and go over some of the political aspects that make their way into software testing. Chapter 13, lucky number 13, is all about testing activities or a testing role. And if you're thinking to yourself, this sounds an awful lot about doing testing, but do you have to be a tester to do it? And if that's what you're thinking, you're right. Up to this point, we have been specifically vague about who is doing the testing. Because, to put it simply, you do not have to be a quote-unquote software tester to do testing and do it well. Just about everybody in an organization can be doing some level of testing and some significant levels of testing. Again, this comes back to what is testing but experimenting on hypotheses. That's the real key point of this. And you do not have to be a quote-unquote software tester to do that. But this opens up a big can of worms in the sense that, well, if you don't have to be a software tester to do software testing, why do we have software testers? Glad you asked. So one thing that's important to consider is how we got to the way that we develop software today versus the way that software had been developed for a number of years. I've had the benefit of a 3-decade career working in software testing that started in 1991 when I was working at Cisco Systems. What we got to see was the fact that creating builds and pushing software was a fairly big and detailed process. It was not something that was done haphazardly. And if a bug was found, especially in desktop software of the time, we used to say that a bug was eternal, in the sense that if you found a bug, it was going to take possibly big efforts to fix it. So a lot of emphasis was placed on doing testing so that we could ensure that we had as few of those as possible. If you got into systems like gaming systems, especially gaming systems that shipped out CD-ROMs, and those CD-ROMs or cartridges, to go back even further than that, before you had hard drives and internet-enabled gaming systems, bugs really were eternal. You ran the risk of, if you had a bug, there was no fixing it. In fact, we had a term that we said in the game testing world of forensic bug hunting. And part of that was not so much just that, hey, we found that there's a problem. We wanted to understand what the problem was, of course, but what we really wanted to do was figure out, was there a workaround for the problem? And if you could figure out that workaround, or if you could alert people that, hey, in this game, if you land at this given point, you're going to drop through the floor and your character is going to disappear. Well, we can set up some barriers, if you will, not in the game itself, but mental barriers to say, as long as I don't go in this area, I'm not going to drop through the floor and the game's not going to get stuck. That's something that we did. And that actively helped us to develop a good process for figuring out how not to get there in the first place. And so testing and testers was very important. However, in and around the year 2000, we started getting extreme programming and the idea that you could push software much more quickly. You could make fixes much more quickly. More to the point, you could push smaller amounts of code. And by virtue of pushing smaller amounts of code, now your testing frameworks and your testing umbrella of things you need to cover becomes a lot smaller. Not in total, but it becomes smaller in the sense that you don't have to do as much to get working software out the door. And so the needs for expansive, exhausting testing, especially testing with a large group, is not as imperative. One could argue that now your developers doing their unit tests and doing basic integration tests are doing a lot of the work that testers would do. Now, is that true? In some organizations, that's what they figured that was exactly what they were going to do. And so they got rid of their testers, their dedicated testers, for a number of things. Some products are so mission critical and so important that getting rid of testers was not going to be a smart idea. But for many things, especially, how will we say this, social products, the ones where you are the product really, and you're getting tools for free to play with and have fun with, your Facebooks, your Instagrams, etc. Those, you could farm out the testing. In fact, you could even test in production. And by doing so, your customers will alert you if something's wrong, and then you can fix it pretty quickly, push it out, and they'd be none the wiser. They think, wait, was I seeing a problem? Oh, now I'm not seeing the problem. Maybe it was my imagination. Or maybe they had a quick turnaround for a problem that was reported. So when we're talking about the fact that some organizations are saying they don't need testers any longer, what they're really saying is they feel that a lot of the big overhead, long, elaborate testing processes with a lot of handoffs and a lot of back and forth is not of high enough value to warrant it. And in some cases, they may be right. But in other cases, especially mission critical software, you may really still want to have that. What this means, though, is that your software testing efforts need to be high value and very important. If you're not providing high value, important information or updates or the ability to see how you are effectively mitigating risk, then some could argue that your testing efforts aren't all that important and maybe they don't need to be done at all. That's a hard pill to swallow, but in some cases it may be true. And in some other cases, it's absolutely not. Ultimately, what we want to do is we, as testers, or whoever is doing the testing in the organization, what we want to do is we want to figure out what are the biggest risks that we face as an organization. What do our software development teams need to be alerted to as far as potential risks that we might face, and how might we mitigate those risks? So one of the things we recommend is do exactly that. Take your product, walk through it, and ask yourself, what are the biggest risks that I currently face? By shipping this product, what could happen? What are the potential downfalls? What do I need to be alert to? Think about things related to security. Think about things related to user experience. Think about things related to data integrity, etc. All of those items are risk items, and some of them are more important than others. But the key things to think about are, what are the things that I want to do to allow me to figure out what these risks really are and test to make sure that we are mitigating them or addressing them effectively, and what areas need more time. What should we do to strengthen those areas, make them more robust, make them less prone to error, less prone to sabotage or corruption? What could we potentially do earlier in the process? Could we, for example, if you're thinking about accessibility, is it something you want to consider late in the project, or do you want to consider accessibility changes early in the project, as early as possible, so that you can put those capabilities into your product directly. And by doing so, you don't have to worry about them later on down the road. Whereas making a product accessible after you've done most of the development might be a big hindrance. And then finally, what activities are you doing that aren't effectively lining up with the risks that you have? What do you think you are doing right now that, based on the risk assessment you've made, are just not worth your time? And if they're not, maybe address those and have a very open conversation about what you should do with them. At this part of the book, we look at two different philosophies, if you will, about software test automation. And they have two terms that we use. The terms we use are faith-based automation and empirical test automation. What does faith-based automation mean? Well, it's exactly that. It's where a promise of automating all the things and having that automation be in place is going to save so much time, so much effort, and those tests are going to be really, really important. And in many cases, it's often a pipe dream. I've been on projects that have been faith-based automation projects, where we go in, we do all this work, we put all this effort in, we make all these automated tests, and then it turns out that they become basically not much value because they're always doing the same things. We know that. We know what those areas are. We've identified them, and we've put them into play. The problem that we face is we're not really doing anything novel or new at that point. We already understand the software. We already understand how to make it work in certain ways. And by virtue of that, a lot of automation gets made that doesn't provide a lot of value. And maybe later on gets scrapped because it's just not doing much of anything, or it's actually not catching things that are of real importance. The thing to consider is software tests, once you've automated them and once you're running them reliably, they're not really testing anymore. What they are doing is they're alerting you if something has changed. Now, there is a value to that. But unless something happens that you have gone in and made some dramatic change that causes a whole bunch of tests to suddenly fail, well, you probably already know, okay, we need to make changes to that because the code base has changed. And then you can modify that. And that's a change basis that you work with. However, beyond that, an argument can be made that if you have a test that you can never make fail based off of varying your data or varying your steps, is it really a worthwhile test? That's a question that you should be asking yourself, is how valuable is my test if it always passes? Can you think of a way to make it so that you can make it fail and then turn around with different parameters and make it pass, and do that regularly? Now you probably have a test that is worth examining and running on the regular, because you have ways of manipulating it that can genuinely fail and you can prove it. And then you have ways that you can change it and you can run it and make sure that it passes and you can prove it. So one of the interesting conversations that we've had about software testing in the past decade or so is this phrase that we use, shift left, that's my left, by the way, and shift right, my right. Shift left and shift right has to do with when are we doing testing? When are we focusing on the test efforts? And we can argue that you can take shift left all the way over to the first initial story workshop. I'm going to borrow a phrase from John Bach. And what I love about this is the idea that we as testers, or whoever is doing the testing, can, in that initial story workshop, we can provoke the requirements. That's the term I want you to think about, provoke the requirements. What does provoke the requirements mean? It means as you are discussing what's going on, you should be actively questioning, what is it about these that we need to be aware of? What is it about the functionality that needs to be addressed? How are we going to put it in? How is it going to be handling the data? What are the things we need to be aware of? What do the requirements ask us to do. And if we can somehow trip it up, how's it going to handle it? So having those conversations early on can be very helpful. Let me give you an example from this. If you are looking at discussing accessibility, one of the key things you can do by having that conversation about accessibility at the very beginning is you can ensure that you are looking at all the areas where accessibility should be implemented and how you can go about doing it. Those conversations are going to be harder later on when you're about to release the software. It's like, oh yeah, by the way, did we consider accessibility for this product? What are the changes we're going to have to make? And then you realize, oh, we might have to make a whole bunch of changes, or we might have to change them in a way that's going to be not very conducive to getting the code out on time. Those are realities. I've been in those conversations before. Shift right is another conversation, and that's where you're looking at what is the code doing after it's out in the wild. How can we look to see how well the software is behaving? And that's where things like A/B tests or production monitoring, performance, bottleneck checking, etc. A lot of areas that you can look at after the software is out into the wild, and you can see what's going on. Good example for this is a feature that's called Pendo. Pendo is something that we use where you can actually go and see, are people actually using the code that you spent all this time creating? It's one thing to say, yes, we need these features, they got to be out there. And then once it's out in the wild, using something like Pendo to go, oh, you know what? No, we're really not doing a whole lot of that. But we're doing a bunch of this other stuff over here that, interestingly enough, we did not really put into our risk requirements. We should probably address that. So there you go. These are some examples of ways that you can have the conversation about when testing happens, and also, effectively speaking, who's doing the testing. Do you need to have a dedicated software tester provoke the requirements in the story development? Maybe, maybe not. Maybe a developer can do that. Afterwards, when the product is shipped out to production, do you need a dedicated software tester to do that? Maybe, maybe not. Perhaps a DevOps engineer will be the one that's responsible for doing the monitoring, or some other business analyst to make sure that everything's happening there. The point is, though, what you need to be alert to this is that testing is occurring. Whether or not a tester is the one doing it, testing is always happening. We do believe that having dedicated testers is valuable, but we also understand that dedicated testers are not needed for every occurrence or every example of testing that gets done. Other people can do that testing. That's absolutely true. But it's probably a good idea to have somebody on your team who really understands testing so that you can be a coach and an advocate for those new people who are coming into doing testing who may not be testers on their own. Next chapter, we talk about ethics. As always, we want to encourage an ongoing conversation with this book. We've written this with a lot of our own experiences, some of our own biases, some of our own approaches to the world, and yes, in this case, some philosophy that we consider to be important. Do you agree with us? Do you disagree with us? Either way, we'd love to have you leave some comments and let's have a discussion about this. And also, are there areas that you feel we haven't effectively addressed? We would love to be able to offer a second edition of this book. And one of the key ways to do that is to have these discussions and see if there's things that we could have covered better, or if there's things that we didn't cover at all that you'd really like to see us do more of. Thanks very much.